go ahead and start recording because it is 8 o'clock, but just give me a second before I teaching destruct. Because I do need to adjust my office hours because after examining the schedule and how everything works in this, in this area, I didn't want to set it before I, actually came to campus. I will be doing my office hours. Okay, this is the right one. On Tuesday, Tuesday and Thursday. Let's see, so. And I'll update the syllabus online. Thursday. Let's say from 1 to 2 p.m. Okay. Oh yeah. In room 509. And by appointment over Zoom. There we go. That covers everything. All right, so those are my office hours. 509, I believe that's where I've got where they've given me a desk. So 1 to 2, so plenty of time after lunch after this class, in other words. Because, this is a long lecture, and you might be worried about that, but let me tell you, don't worry about that. Let's go ahead. Rendered it. So now let's go ahead and actually open up the finished product. So I'll go over the syllabus and I'm going to explain how this class works. All right, so if you haven't figured it out, I'm Professor Andrew Rosen. I am a professor of computer science, I'm from main campus in Philadelphia. I taught here previously back in 2018 for a summer, and then during COVID, I also taught this course online. So like this one you're taking right now, I did it online, and let me tell you, that was very interesting to teach with the time difference, but it worked out just fine. So you've all taken 1068, I believe, right? How recently have you taken it? Did you take it last semester? Yeah? Or everybody? Is that the case for everybody? The Object-Oriented Programming in Java class. Yeah, okay. Yeah, so this is a follow-up to that class, and if it was like more than a semester ago, don't worry, because this first class and the first exercise we're going to do is all about reviewing that. So this class, it's all about learning how to organize data, or learning how computer organizes data in a way that's useful for us to store and retrieve it. Not like in the database kind of sense, but in the more fundamental, these are what we would use to build databases kind of things. So talking about array lists, linked lists, stacks, queues, trees, heaps, hash tables and graphs, as well as a couple of different smattering of topics in there. For instance, we can't really talk about trees unless we do recursion. And so we'll go into fairly deep into different techniques for recursion. We'll go through recursive backtracking, which is an extremely useful problem-solving process. We're going to go into heaps, which, as I mentioned, which are useful for building priority queues, Huffman trees, which are these ways for doing encoding. We'll take a look at sorting algorithms as well, because that helps play off of the algorithms. So the main big thing about this class that's going to make it different and actually make this feasible to do at 8 a.m. in the morning is that it's a flipped classroom. And now if you don't have any experience with that, what that means is that I am going to be saving you hopefully a lot of time here. What I've done is that I've recorded my lectures all in advance. And the idea here is that you're going to do your lecture, you're going to watch the lectures outside of the class. And inside the classroom, what are you going to do instead? You're going to do the stuff you would normally do outside the class, which is your homework. Your homework is done in the class with me so that I can help you, so that when you get stuck, you don't bang your head against the wall for 3 hours. And instead, you can just ask me and I can help you point you in the right direction. Or you can ask your classmate if you want to work together, So the idea here is that especially during the summer with these 3-hour blocks, pretty much all your assignments get done in class. Then you've got to watch your lectures. For each module has less than 2 hours. It's like between an hour and a half to 2 hours per module. And again, I've done this during the summer. I've also done this when I teach this course once a week in the evening. And my experience has been these very long stretches of class are very good because you're not here listening to me drone on except for like this very first lecture where I'm going to be talking about the way the class works. Instead, you're actually able to work at your own pace, take a break if you need it, because 3 hours is a long time to stay still. And, the room can get a bit warm, so maybe you need to grab some water or something. Time and place. Okay, I don't know why they have us put it in the syllabus when you figure it out anyway from the course schedule, but there it is. If I get sick, I'll hold it over Zoom, assuming, if I get sick, but not so sick that I can't, operate, then I'll hold it over Zoom. And I'll let you know in advance about that. So you need to have a C or better in Math Concepts for Computer I forget what it's called, but it's the Math Concepts for Computer Science 1 and Object-Oriented Programming. So this assumption is that you can think abstractly and that you know how to work in Java. If you got only a C in 1068, you may definitely need to crack that. You may be not prepared, so in which case you're signing up for summer, you definitely want to spend today and tomorrow, definitely cracking down and reviewing all this stuff. Fortunately, that whole flipped classroom thing, the first module is literally reviewing the object-oriented programming part of 1068. So I highly recommend a strong laptop. That you have a laptop. Do you have a laptop? Yeah. Okay. Yeah, you'll definitely want to have a laptop for this class because you'll be working on your stuff. If you don't have a laptop that you can rely on, talk to me and I will help you by I can help you figure out something in your budget. Trust me, there's something in your budget. I can help you find one. Our textbook is Data Structures, Abstraction, and Design. The slides should be under, I believe I have the slides for this textbook under Files. It's not listed anywhere, but if you go to Files, you should be able to see there should be slides over here for each of the 10 chapters of the textbook. Interesting, and actually I go through most of these chapters. They've restructured it so that they added a chapter for testing and combined the chapters for stacks and queues. But in reality, all we really skip, we will probably skip only chapter 9, which is self-balancing trees. I might decide to throw in a homework assignment on self-balancing trees to see how that works out. Again, office hours, email me if you need to meet. I teach Tuesday and Thursday, and until middle of June, I don't have anything else going on. After June, my family's so in the middle of June, my wife and kid are coming over, and so I might start doing stuff over the weekend. But other than that, it's fine. So this class, I'm pretty sure I've got a good schedule worked out for it because one class roughly translates to about a week of stuff. I've got the due dates for each of the assignments listed here. If you need more time and you're struggling, please let me know. I'm generally very flexible about this. Especially after we get to recursion, people start definitely going at their own pace. But when we get to the exams, that's definitely when you want to be caught up on stuff. Exam 1 will cover up through linked list. These first 5 lectures are generally the hardest lift because you got to really understand how your references and variables work, or at least abstractly how they work. And the key point to always remember is that the memory location is on the right, and that gets stored on the variable on the left. That's how it always works. Okay. If I am talking too fast, also please let me know. I can slow down. I'm just a very excitable person in general. Exam 1, I'm fairly sure it's going to be on in our 6th lecture. And exam 2, I'm not sure if it will be on July 4th or July 6th. That's why I've got alternate set up there. And then again, we've got these, we've got our study days and final exams at the end. Okay, I expect you to show up to class. I mean, you're paying for the class, so you might as well show up. If you think you're ill, please let me know, and I can always boot up Zoom so you can join remotely. But please don't, but please only, ask for that if you're actually sick, especially with such a small class. You're having if you feel like depressed, or you have mental health issues, or there's just other stuff in your life going on or even if life is just getting too crazy for you, and you find that it's getting really hard to do stuff and get stuff done, reach out to me so that I can work out a good schedule for you to get your work done, and I can make accommodations with time and stuff like that. So, but the earlier you tell me about it, the more help I can be. The wrong time to tell me that you've been having struggles all semester is like the day before the final exam. That's generally the wrong time. And let me tell you, this is mainly an issue with freshmen in the Python course, where I have to teach about 180 students there. That where I have a couple students who they don't communicate all semester, and then it turns out their life has been a complete poop show for the past semester. I'm like, well, had you told me early on, we could have worked through this. If you've got the need for an accommodation, please let me know. I will make I'll make any reasonable accommodation I can. I have yet to find an accommodation that's unreasonable. Yeah. As soon as I find an unreasonable accommodation, I'll let you know. But I haven't found one for this class that's unreasonable. I will record these lectures. If you're going to record them, please let me know. I don't know how the laws work in Japan with non-consensual recording of stuff, but it's temple policy that you got to ask for permission to call that. I mean, in Pennsylvania, I'd be talking about the difference between a two-party consent state and a one-party consent state, but yeah, I don't know the laws here. So this is the rubric I used last semester for where the grade breakdowns are. The guarantees is that 90s and above will always be A's, not A minuses. B's, 80 and above will always be a B, not B minus. The minuses are used to the minuses are used to bump students from one. If I feel like there isn't much difference between. So what I did, how did I get 88 for that? Basically what I did is that in a larger class, I typically sort from high to low, and then I look where there's a point, at least a point gap between scores, So there's not really much of a difference if you've got a couple, the tenths of a point difference between students. So, but as soon as I see a nice cutoff, that's where I try to make it, where it would be inappropriate to round a student up. And that's where and so if you've been rounded up, that's an A minus. If you just missed the cutoff, that was a B, that was a plus. So the lowest you can get in this class if you participate is a D. F's are reserved for people who cheat or fail to do the majority of the work. This just has to do with my ire for financial aids and the contradictory instructions they sometimes give us. So I try not to even bother with the paperwork sometimes. So there is some extra credit on the assignments and on the assignments, namely that you'll sometimes have the option of doing harder versions of an assignment if you so choose. I generally do not give out extra credit, although we do have one already posted for, I don't give out extra credit for a single student. The extra credit's available for everybody, is there. So let me go ahead and go into this. So first off, quizzes. You have quizzes on Canvas. They are non-stressful quizzes. In other words, you can take them as many times as you want. They're unproctored. They're basically, am I keeping up with the material? Do I understand the material? The only penalty there should be is that it locks you out for 15 minutes after you take between attempts. So it's just enough time for it to be annoying without being, really annoying. But also long enough that you just can't spam and guess the answers, if that makes sense. Labs and assignments are a quarter of your grade. In other words, those are the stuff we're doing in class. They're the same thing. The lab portion I mean, again, for this class it really works because normally it'd be lecture and lab. It's all just one big lab essentially. Exam 1 and exam 2 are worth 20% and the final is worth 25%. To get a grade on your assignment, you've got to submit it online to Canvas. And then you can demo it to me, which is not a problem with this class. What that means is that you're just going to show me your assignment and that it runs, and I might ask you some questions about it. This is so you can get some practice explaining your code to other people. That's one of the big reasons I do this. Because if you're going to be working with other people, you got to be able to explain your code. Because, yeah, I mean, have you tried explaining have you tried looking at the code that you wrote last week and you're like, man, that code was written by a madman. It was, I have no idea what's going on there. So I accept your late work. If there's no good reason that it's late, like you had a medical emergency, or you were sick, or or you were busy helping somebody who really needed help. If there wasn't a good reason for it to be late, then my late penalty is 5 points per day. So it's very generous, and I cap it out at 50% because during normal semesters, it's very easy for students to make mistakes, and then I am a big believer in second chances. Exams are the only the only hard due dates of the semester. Those also have a late penalty. It's much more strict, which is that it's 1/10 of a point per minute if it's for every minute it's late. But if you do the math, that means that if you take an extra hour on your exam, it's only 6 points off. This is so that now why in the world is this? Because a lot of times for exams, I know that it's the time pressure. Oh God, I only have this much amount of time to get the exam done. That makes it really stressful for students. So here, I balance that out. It's not nothing, but it's enough that you're like, oh, that might make the difference between an A and a B. But, I mean, if a question's like worth 20 points, and you turn it in an hour late, but you get the question right, that's definitely a net gain. So, don't worry about the time. Just keep it in the back of your mind. But in general, these exams are going to be electronic. They're going to be on your laptop, or and if Murphy's Law does happen, we can always. I think you guys are able to rent laptops, right? Borrow laptops. Yeah. Or if we need to, we can even print out the exam. It's fine. But generally I try to make it as reasonable, the exams as reasonable a facsimile as you would actually be coding. So you're allowed a lot of notes and stuff like that. The only thing I'll explain the exact details later, but essentially the only thing you can't do is use Google to look up answers and stuff like that. So if it's on Canvas, it's on or it's on your OneDrive, it's fair game. Final exam, I don't bother listing that in class because that's just a area for error. I'll announce it later on, whenever that is. Okay, I've mentioned about the late penalties. Don't worry about this 2 weeks thing because you're going to be here pretty much every day. This is for class a lot of times for students who never show up, and stuff like that. General academic honesty. So this is a big giant wall of text because but generally the idea here is I've adapted it from Harvard CS50 class. I try to be reasonable about it. I personally believe that the best way to master material is to teach it to other people. So I do encourage collaboration. So how can we easily draw the line between helping somebody and you essentially giving somebody the answer? And the answer is fairly straightforward. If you're the person who needs help, you can show your code to other people. If you are doing the helping, though, don't show people your full answer. Make sense? Right? You can send your message. You can. So I have a Discord channel, by the way, for this class. In fact, it is fairly large because it's the same Discord channel I use every semester. So I still have a bunch of former students for this class logged into there, and then we also have a bunch of graduate students who are taking an accelerated version of 1068 and 2168 glommed together in one class, essentially, at the same time. So feel free to like, okay, I'm having trouble with this code. Can anybody help me? And you paste your code. That's perfectly reasonable. If you make a mistake, and you know, as long as your intention was fine, I'll probably just delete the message and just, you know, message, hey, that wasn't a, you know, just, you know, because obviously if you're posting it out in the open, you probably didn't mean to be academically dishonest. But generally, you know, again, the idea here is that if you need help, it's okay to post your code. If you're trying to help somebody else, you know, don't post your full answers. If you're having trouble with an assignment, please send me an email so we can, so I can, you know, or meet with me. I'm happy to walk you through to get you to the correct answer. Don't go to Chegg. I'm familiar with actually a lot of the answers that have been submitted onto Chegg because I don't change my assignments too much because I like my assignments very much. And why should I rob you of a good learning experience just because, you know, some people cheat? In fact, like one of our homeworks, the 8 Queens problem, has been a homework problem since like computer science classes were a thing. And so there's, again, the answers are out there. It's like a very famous problem. But why should you lose the learning opportunity and the challenge? Also, don't just ask ChatGPT for a solution either. Although if you do want to do that, you know, consult with me because I'm actually very interested in the stuff ChatGPT does. I do a bit of side not research but hobby stuff with AI. I've done some AI generated music, so I'm very happy about that. I've used ChatGPT to actually generate some exam questions on some of our exams. Generally of the sense of these were questions that were generated by ChatGPT. Some of them are valid questions. In other words, they make sense. Some of them don't make sense. Please tell me the difference. You know, please tell me which is which. You know. Yeah. So anyway, I have a list of reasonable and not reasonable. Generally, there's a few things though that like I want to clarify. Like you might be like going like, okay, how do I print out everything in an array, or how do I like do something very specific? Like I'm looking up trying to find something that like requires 2 function calls to do that are built into Java. If you're like find something on Stack Overflow that answers like a portion of the question, just cite it. And citing in my class is very easy. We don't do MLA, we don't do IEEE or anything. Just grab the URL, put it in a comment. Because if you cite it, the worst I'm going to say is, could you do it again yourself? No, I won't, because if you cite it, you're not trying to be dishonest, at least as far as I'm concerned. All right. So obviously we can just simply this is up for change and stuff like that. You have rights and the like. I don't know how those rights differ from main campus, but you do have some rights, including the ability to, at least on main campus, to not take more than 2 final exams on one day. That's like one of the things that is explicitly listed. So yeah. So any questions about this? I will be uploading this the full details of this. But any questions about that? Okay. So our Canvas course, I've got up the, why does it say fall 2022? Jeez. All right, so there's my picture. There's the textbook. Again, let's see. Now, with that aside, again, the slides for this textbook are also under the files. So the other important links are, we've got Discord and, the invite to Discord. If you haven't used Discord again before, it's like Slack or any other big chat room. And I've got it sorted by sections for class and stuff. My YouTube channel, where I'll post the recordings, are over here. I don't need you to like or subscribe. I don't monetize the channel at all. I posted on YouTube. I posted on YouTube because I know if it's on YouTube, it's basically available all the time, and it works on every device. And Vimeo costs money. So and then I'll post a link. So here's a link to the lecture recordings, it will be in a specific page. So obviously you'll be able to find it on the channel, but you don't want to necessarily navigate there. So once I've got a recording, I'll post a playlist on this page, which you can access by clicking here or here. It'll bring you to this page, and I'll move this playlist down, and over here you can see I have all the previous semesters in case you need references for all these things. So you can see that I've got all the previous semesters there. Each of the modules, they contain their own, the videos that are appropriate. So these are the videos that are for today's lecture. In general, you want to try to have like the videos watched before the lecture. So for instance, for next lecture, you'll want to have the array list videos watched. The reason why it doesn't matter for the first one too much is because, again, this is all review stuff you should already know. Specifically, it's over object-oriented program, what's object and classes, was inheritance, what is polymorphism. The only thing you may not be familiar of is the for each loop, and that's like a 2-minute video. I try to keep these videos nice and broken up so that you no more than 15 minutes, because that's about the limit. That's where the human attention span starts having a lot of decreasing returns. So yeah, the array list videos, and typically when I'm going over data structures, the first videos we basically talk about like what is this data structure, how do you use it, and then we talk about how do we build it from scratch. The first video is almost always a nice, very polished overview video that Temple helped fund, so that was pretty cool. They're like we took a lot of inspiration from Crash Course for these things, and we kept them very snazzy. We recorded them all in one day. It was pretty cool. So yeah, and then I have a bunch of code that I posted here. Also, I'm the grader for this course. Sorry, I'm the TA for this course because I don't have any other TAs. This is normally something I would use to sign up for office hours, but we don't have enough students to need that. You just email me and let me know. Okay. So, all right. With that, let's take a look at the first assignment, and we'll get started working on it today. Okay. So this is not one I take credit for. There's a group called SigC, which is from the Association of Computational Machinery, but it stands for Special Interest Group Computer Science Education. And basically it's for computer science educators, and it's where if you're going to be publishing papers on computer science education, that's where you'd go to, one of the many places at least. And they have a nice big repository of these things called Nifty assignments that are presented every year, where people just like present their assignment. They submit assignments, and people who win get assignments that get to present assignments they're proud of making. And this is one of those. So, I try to find as many interesting assignments as I can. So here you're going to be downloading a nice big zip file called hunt.zip. Before I get started, what editors do you all use? Because I don't really care what you use so long as it works for you. NetBeans? NetBeans? All right. I'm a big fan of IntelliJ. I find it to do a lot of work for you, but again, if you don't, if you want to use what works for you, like if you really like VS Code, then by all means use VS Code. So for over here, I'll go ahead and create a new So what I'll do so let me go ahead and kind of start it from scratch. So what I'll do is I'll create a new project. Fox Rabbit 2023 Summer. I'm just giving it a project name, and I'm opening a repository for it. And what I'll do, and this is going to be very similar to what's going to be happening in NetBeans, by the way, where if we go to so I'm going to go ahead and I'm going to take the zip file. I'm going to extract all the files from it. I know it's a bit hard to read the tiny text there. Don't worry. When we're actually showing you the code, it's going to be nice and big. I've gotten into the habit of, I used to just blow up the text size just because I'm always presenting, but now I'm like, okay, I can't live without giant text. Once you've extracted it all, select all your files. This works whether you're in a Mac or in a PC. So if you're in Explorer or in Finder, just take all those files, and what you want to do is drag it to this SRC folder. Same if you're working in NetBeans. That's how you want to make sure it's going to work. Because if you just try opening it, individually, it's not. You're gonna have some issues. So just drag it into that SRC folder. Both NetBeans and IntelliJ and Eclipse, they all have an indicator as to whether or not that those files are external or internal, right? For IntelliJ, it will give you like a C symbol over here, like it's a class over here. So we've got like all these classes here. That looks complicated. Don't worry about it. You only first off, you're only ever going to be writing code in one class, and that's Rabbit. Okay. So I'm going to go ahead and show you what this program is, and then we're going to walk through the individual portions of it. Okay. This is also the only assignment where you won't get full credit on it for doing it, because your score corresponds to your survival rate. So Rabbit Hunt, or Fox and Rabbit as we call it, and there's a PDF that goes over all this stuff as well, is a simulation of a fox chasing a rabbit. It's a turn-based game. Now, don't worry that when it boots up, don't worry that it's on a blank screen or whatnot. But we get a window, and we get some buttons. So just hit run, and it will start generating. Now we've got a big red dot. I'm just going to slow it down. We've got a big red dot, and it's chasing the smaller yellow dot. The red dot is our fox. It is hungry, and it wants to eat the rabbit. And it wins, and the fox wins if it is able to find the rabbit and jump on it. Okay? And the rabbit wins if it survives for 100 turns. A turn being basically the fox both the fox and the rabbit getting their chance to move. Now it's it's a turn-based game, so the fox moves, then the rabbit moves. They take turns moving. They don't move at the same time. Okay. Now, as you can see, the fox is basically winning pretty much every time. And the reason for this is that the fox has a strategy. It finds the rabbit and eats it. The rabbit, even without like knowing anything else about the code, you'll be able to see that the rabbit has a terrible strategy for this. Let's go ahead. So here's the rabbit. It is a animal, right? Makes sense, right? Rabbit is an animal. Extends the animal class, so it gets a bunch of stuff from that. We'll go over that later. It's got constructor, which just simply says, which is very basic. It just simply says, hey, let's go and just build it like I'm an animal. Now, and the function decide move, that is the only function you care about. That is where you're going to be coding. That is where basically pretty much the only place you need to be coding, although you can edit anything in Rabbit you want. Now, int decide move, return random move model.min direction model.max direction. So now we can see why the rabbit is doing terrible, because he's essentially moving at random in one of the 8 possible directions, north, south, east, west, and then, the diagonals, which if you think about that over hundreds of thousands of moves, that's just staying still. It's Brownian motion, in other words. So and whereas the fox has a very clear strategy. If we open this up and take a look at the fox has a very clear strategy. It's got like all this code here. It's useful to take a look at this code, and we will. But I will point out here, you don't want to just simply take the fox's code and try to reverse it, like do the opposite, because the fox is a predator. it has a very different objectives of what it needs to do. It needs to be moving all the time. And if you think about it, prey animals, they don't move all the time. They stay put. They conserve their energy. They go and get food, and then they stay put and rest. But predators, they need to hunt. So it has a bunch of code to reflect that. So it's got a strategy. Now the way this works and the way you get your grade is that I have a class here called grader. And it simulates 300 of these games without doing the graphics portion of these. The graphics here is so you can see what happens, but the grader tells you what the effects of it is going to be. Okay, so we run it. The rabbit escapes 2 times out of 300 or 0% of the time. So your grade is 0. Now the way this works is that your grade for this is on a square root curve. What does that mean? It means that what I'm going to do is that it will do the math for you, but your grade, your raw grade for the survival portion of this is you take your survival rate, take the square root of it, and then multiply by 10. So an 81% survival rate will give you a 90. Make sense? A 64% survival rate will give you an 80 a grade. Now the reason I do this is that so that there's a very, very clear diminishing return. So because I don't want you to obsess over trying to get 100% survival rate. There's only one way to get 100% in this, and that's to cheat. If you're able to figure that out, I will honor it, but I will also ask you to actually, do it for real, if that makes sense. So if you do figure out how to cheat on this assignment, and by cheat, I mean like make the rabbit does the cheating, right? If you're able to figure that out, then great, good on you. I'll honor that, but I will ask you to actually also do that. Do it for real so you get the experience of thinking through it. So this program has a lot of classes in it, and that's because it is doing something. It is using a very classical model of graphics programming called the model view controller. So the model is all this internal code. Notice how that we could run the grader and it didn't bother doing any of the graphics? That's because it has a model, and the model is independent from anything else. In fact, we have something over here. We have a class over here called the model, and it contains all the cool data that we care about for this class that I will go over later. Okay, those errors are not errors, they're documentation things. Okay. So the model view controller over here, the view is literally seeing the rabbit. Let's see. Let me go ahead and run it again. Rabbit hunt. So the view is literally what a human would look at. It's not very important for a computer because the computer can't really, unless you're working like with vision and stuff, it's not going to be able to figure out what's going on with that. It's this diagram over here. And the controller is the buttons, the reset, replay, the start. So let's go over the controller first. Reset does obvious things. It generates the map. Notice the map is generated at random. So first off, let's explain the map. So the map, obviously, it has our fox over here, and it has our rabbit. These green little star things are bushes. They block line of sight and they block movement. I'll talk about line of sight in a second. Also, the game is bounded. It's not like Pac-Man where you can walk off one side and you wrap around. There's essentially a wall on all 4 sides. Make sense to everybody? So the way this works is with line of sight is that, as you can see here when I run step, there's a function called look where you look in a direction, and basically it tells you in that direction what is the thing that stops your line of sight. Is it a wall, is it a bush, or is it the rabbit or a fox? Make sense? So, and we can see that over here in the fox code, where, as you can see, it's got basically a laser eye shooting out at everything. It's this loop over here, which is probably the only thing you want to bother copying, which is this loop, which is for in model.min direction, model.max direction. So rather than like trying to remember north, south, east, west, it just simply says 0 and 7. And rather than trying to remember, okay, is 0 north or is it south, Model has those already figured out for you. It tells you, okay, just if you want to go north, instead use model.n to reference north. Okay? I'm sorry this is taking a while to go over, but it is, I want to make sure you get plenty of, this is probably the most complicated program I'll have to talk about in the entire semester, but it's a fun one to solve. Okay, so here, what we can see here is that it says, okay, look at the minimum direction, iterate up to and include the max direction. The most common thing you'll see here is that the most common error I see here is that students forget to do, they do less than rather than less than or equal to. And that brings me to another point. I should explain what's going on with my code over here because that doesn't work normally. A less than or equals. So what I'm doing is that IntelliJ supports a function called ligatures, which people either love or hate. Basically, if you're ever typing and you note in English, you'll notice that there is this that if you do an F and an I next to each other, it doesn't actually do that in most fonts. Instead, it'll do something like this, like an F over the I, so that, and it combines two characters in a nice fancy way. That's built into a lot of fonts, and so this exploits it and says if there's a less than or an equal sign together, just draw those two characters very nicely next to each other. I find it makes it easier for me to read my code. Some people hate it, especially with these fat equals signs that it does for double equals. But I personally love the fact that if I do a not equals, it looks like that. Again, it's a love it or hate it kind of thing. I love it, and I totally understand if you hate it. It's, again, just don't do it on your code if you hate it. But anyway, so you look at, it goes through every direction, and then it calls the look function. Now, the look function is defined by the parent class, so you don't have to code it up or anything. A lot of the stuff that you're going to be using is defined by the parent, but the most important things that basically you'll be using in this class are the look function to see, hey, do I see the fox? And it uses the distance function, which does the same thing as look, only instead of telling you what's there, it tells you how far you are from it. And then the other thing, how do you actually move? Well, the decide move returns an int, okay? It returns an int, and it says, hey, I want to, it says let's return an int, and that int is the direction you want to move in. If it's a valid move, you'll make that move. If it's an invalid move, like you're trying to move through a bush or something, you're just going to stay put. Okay. So what we're going to do here is that we will, so your first task, once I stop doing this, is you'll want to write a loop that looks in all directions for the fox. And if you see the fox, move directly away from the fox. That's not a winning strategy because you'll just crash into a wall eventually and the fox will catch you and you'll get eaten. But it's a great way for just being able to figure out the way to handle this. The fox uses a bunch of things like can move in a direction, which is useful for later, but it tells you that, if I can move in the current direction, I do move in that direction. The one thing that's worth mentioning is this function over here, the model.turn. So that is the other, so I said there's two functions you care about. Well, three if you include can move, but that's very obvious as to what it does. The turn is a bit less obvious. The idea here is that it would be very tedious for you to kind of write the code, okay, if the fox is to the north, I want to go this way. If the fox is to the south, I want to go this way. If the fox is to the east, I want to go, that's terrible. Instead, because, it's a compass, and there's 8 directions, you can use modular arithmetic to figure that out. But rather than making you do all the modular arithmetic, the author of this code already did it for you. So model.turn does is that it takes in an initial direction and the number of degrees you want to turn clockwise, and the number of 45 degrees you want to turn clockwise. So, in other words, if let that be 0, okay, let that direction be 0, which is north. If I pass in 0 and 2, then the direction that model.turn will return is 0, 1, 2. It will return east. If you pass in 4, it will say that way. So what you can do is, in conjunction of using look, you can say, okay, I'm going to look in direction I. If I see, and let's say I see the fox in that direction, that is direction I. Which direction is that? I don't care. It's direction I. That's all I care about. And if I want to move directly away, I would say I and 4. So 1, 2, 3, 4, and now I'm directly away. It's the number of 45-degree turns. So model.turn will make a whole, basically it cuts, it eighths, it turns into 1/8 the amount of code you have to write for this, you know. And then you also don't have to worry about all the directions because it's all relative directions now. So there are two primary strategies for winning this game. One I find, there's one that, and I find one is, or rather there's two primary strategies that people come up with for this game, thinking about this. The first is less successful, but generally the first people think about, which is, if you're familiar with MMORPGs, it is the kiting strategy, where basically the fox sees you, and then you run away and try not to let it catch you, right? Kiting refers to basically this tactic in MMORPGs, where one player attacks a big boss and goes, look at me, attack me, where the rest of the party attacks that, and then he runs away from that, while the rest of the party hits it with damage over time, typically, and they just try to run out the clock. And that's exactly what you're doing here. You're just trying to run out the clock here. It's a bit hard because that requires you to steer the rabbit, and that can be a bit difficult. I mean, ostensibly, if you play perfectly, he shouldn't be able to catch you ever, unless, because of the randomization of the board, you get extremely unlucky and he just accidentally lands on you before you can have the chance to see him. The other strategy, give me a second, is to exploit the fact that this is line of sight base. And so the other strategy is to play like a prey animal. Or play like a prey animal. Okay. Let's see, I should have my pen in here somewhere. There we go. Yay. So you'll find that my laptop is wonky and I love it. And one of the reasons I love it, of course, is because I've got this beautiful ability to write on it. Which unfortunately means that I do have to subject you to my horrible handwriting. I should, it's so bad that I probably should have gone into medicine as opposed to computer science. That's how bad my handwriting is. So let's go ahead and use rainbow crayon for that, because why not? Because I'm 5 years old at heart. All right, so so suppose we have our, so let this be our fox. Let me go ahead and just draw an F for our fox, right? And we've got, let's see, we've got this direction. So if he's looking and doing his look function, right? He's got all these directions he's looking in. But we're on a grid, okay? Which means that these areas over here, the areas between the arrows, these are blind spots. And the further away you are, the bigger that blind spot is. So the way this strategy works is fairly simple, okay? Let's say you're the rabbit, okay? What you do is that you just kind of chill. Don't move anywhere. It's his job to find you. You don't need to find him. So you just chill, and here's the thing. The way this program works is that you look around, and then you return what move you're doing. You don't get any information until it's any new information until it's your turn again. So if you're staying still and the fox moves into your line of sight, you suddenly have an opportunity before he sees you to move out of his line of sight. Make sense? So in that case, you want to try moving into one of these blind spots. Probably don't want to go in this direction. And moving away is kind of only a last resort if you can't move further, if you can't move, to the sides or anything. Now, this strategy has a high success rate. You can get about a 90% survival rate depending on which order you try to move in. And interestingly enough, going right versus left or left versus right does have a dramatic impact on your score. We're talking about the difference between about like a 20% difference on your survival rate, because the box does have a bias in which way he likes to move. So with that, you'll want to get it working, and then you'll want to try to experiment with working code in this kind. Once you understand the code base and understand all these tools I've kind of given you, it takes you about a working strategy can be anywhere between 15 to 20 lines of code that will get you around a 90. Now, to get above a 90, I'll talk about that after we get our fox moving. All right, or a rabbit moving. So everybody good on this? Everybody good to get started? All right, so I will go ahead and stop recording, and